Yeah.
Hello everyone, welcome to my latest video. So what you see behind me is a shift register that I've built. It's a computer device machine, and I'll show you about it as we go on. But first, I just wanted to talk a little bit about what I'm doing, why I'm doing this, because I really just hope that these videos can help people conceptualize basic computing components and also show people different interesting ways to play with the Dragon Quest Builders blocks. So I also just really like making these sort of computer circuits. It's a really fun way to think about computer circuits, and no, not that many people are doing this in this game. So I thought it's a fun way to do this. So in a previous video, I gave a crash course on binary and how we can represent binary numbers in these game blocks, but it's not completely necessary. But if you don't have any idea how ones and zeros are used in computing, then my video with a binary counter would be worth checking out. So try to check that out if you're curious. I'm just trying to make these concepts really approachable for everybody who's watching. If they learn something about computers or about digital logic, that's awesome. And if not, just enjoy the video. So ask me any questions. I'd love to try to help you understand. So this is my pseudo shift register machine. I'm gonna run through it real quick so you can kind of see what it looks like. So this is all just repeated machinery here for the most part. And it's a shift register. So what does a shift register do? And it's not a proper shift register. It really only mimics a shift register, but it does that in a really, it does that really well. It mimics a serial shift register very well. And what it does is it temporarily stores and shifts a binary word, which is like a string of bits, so ones and zeros, for quick references and computations. So this is something that is inside processors. So it's not proper computer memory. It's not how they use, RAM or long-term storage or anything. But it is a pseudo-memory device, and banks of these registers were used for memory in some of the really earliest computers. So true registers can do serial shifting, which is what this one does. It'll shift bits straight down this line. Other registers can do parallel loading and parallel outputs, which turns out to be kind of difficult in this game, and I'll maybe get to that, and I'm going to try to do that later in another video. So what else? So this register really works in one direction. So I can load a bit from one side. In this case, it's the side I'm standing on, which will be, when I operate it, it will be on the left. So you'll see there's a red and black boxes there. The red and black on the bottom, those designate my sides. So I can load a bit from this side, and I can pass it along from left to right. And so this is what's called sequential logic, which is contrasted with combinational logic. And sequential logic takes previous events into account when performing the logic, so it remembers. So here's the sort of approximation of D flip-flop that I've made. This is the basic component, and you see this is basically one stage of this machine. So this machine has 5 stages plus this load stage that I'll sort of talk about. This is sort of where I program either a 1 or a 0 into the machine. Okay, so here I've made one side black and the other red. And electrical conventions designate red for high voltage and black for low or ground. So here the red is 1 and the black is 0. That's just a convention. It's just what I've called this machine. You can kind of do whatever you want, but this is how I call a button, any button press, a 1 or a 0. I just sort of named it that, right? So I just sort of declared it to be so, and that's sort of a convention you get into with programming and languages. It's sort of you're kind of making it up, right? But it's quite functional. You'll see. All right, so on the top here, we have 2 gates. On the red side is a 1. This is the 1 gate, and on this side is a 0 gate. And on the top here, this stage is called this is like the state of the machine. So it's either going to be in a state of 0, which means I have water flowing to the 0 side, or it can be in a state of 1, which means there's water flowing to the red side. So it cannot be both, or it should never be both, and it's not going to be neither. It needs to be one or the other. So if neither one's on, it doesn't really have a state because no water can flow and I can't operate those water wheels. So it's going to be one or the other. Next, down below here, you have the first stage of these two gates, which is this one. Now these are the clock gates. Notice they both work at the same time, and that's how I'm going to clock or run this machine for a cycle. You notice that these water wheels will actuate right here. So if either one of these water wheels presses, it operates for a cycle, notice these arrow buttons come back to the back and move around to hit that. So when the clock runs, if one of these wheels turns, they will eventually turn itself back off. So it'll only run for one cycle. That's what the clock does. And finally, these rear gates, these are the enable gates. So these are kind of just unique to this game and this situation. I'll sort of show you what they need to be doing. But the arrows here, on both sides, they make sure that I don't operate both of sides at the same time because I don't want that. So you notice that, again, if I put this, okay, so right now my light block is off, so I'm going to turn it to a state of 1. I can enable that side, and then I can clock it, and I'll just hit this one here. And so, because the enable's on and I clocked it, we're going to turn that light on. Alright, so that's the basic idea. This is sort of one stage, but if you notice, there's more to these because they're all hooked up in series. So we'll see how that operates, but don't worry, I will explain it. It's a lot to go over right now though. Okay, so basically, again, there are 3 inputs for each of these stages. There's the state of the stage. So it's in a state of 0 or 1. Those are the top gates. There's the clock, and then there's the enable. So we need all 3 of those. So before I show all the other button pathways on the whole machine, I'm going to run a few cycles to show you how this sort of works. So lots of buttons here. Most of these are for the clocks, but so anyway. So if you notice actually let's look really quickly at this whole machine. You notice the black wheels on this side, they're all set to 0. Right? So if the water's flowing on this side, then each of these is in a state of 0. And I also have light boxes on the top that will light up when it's in a state of 1, so we can actually see it a little bit easier when I'm running it. So these are all hooked up. This is, I need to enable, well, I need to turn it to 1 is what I need to do. So let's go push a 1 in. So this right here, the red, that makes it a 1. It's good to go. I'm going to clock it right here. This hits all of the clocks. So that far left stage, that's my load. That's not actually a bit itself. That's how I load in a bit from the left side. And so there we go. So we have a 1, and then the rest of these are still 0. But you notice those clocks, all those clock gates ran at the same time. So I'll show you more on how I did that, but it's just good to notice. So I'm going to go back to a 0 just so you sort of see the simplest case is if I alternate the loaded bits. So now I'm going to load in a 0. Notice that red wheel right there in the middle, the red wheel behind me, that's moving. So that means that 1 is going to get pushed to the right. And at the same time, a 0 got pushed into that first bit as well. So now it's 0, 1. So let's go back to add another 1. So this will shift whatever you put into it, and it'll shift it all the way to the right. All right, 1, 0, and 1. So it'll carry that all the way across. So again, I can only load 1 bit at a time from the left side with this particular machine, but it does that really well. It also is good to note here that, again, the way this is built, it works best when you're starting everything at 0, although it can take inputs if everything is a 1 as well. It's just sort of easier to see if you start everything at 0. But they do have to start in a state. Like I said, those top gates have to be either 1 or 0 for this to run. It's very easy to set it all to 0. I can do it right here with pushing this as a 0 and then hitting that clock 5 times. Very easy. All right, so this is what the machine does. We are shifting these bits to the right, loading them from the left side, and it shifts it all the way to the right. This is what it does. And the first one that I loaded, right, when I first loaded the one here, we didn't lose it. It still exists. It's right there. It's just being pushed to the right, but it's still in this machine. It's remembering it, which is actually really cool. That's what we want. That's what's sort of interesting about this. So we can add more inputs, as I just did, and when we get, let's add a 0 here. So once I get a 1 to the end, it's actually going to push out a 1 on this light box. So it's going to turn this light box on. Notice the red wheel here is aimed at that box, and this black wheel's aimed at the box as well. So the black one's going to turn it off. That's a 0. So it's really just simple, easy way visually to see it with these light boxes. And let's put in a 1 again. Just alternating is the easiest, most simple case, but it'll handle multiple inputs of the same type. But it's sort of a special case, and that's why I want to say that for later. So notice now, like, each of these wheels are turning. At the beginning, those far right ones weren't turning because they weren't receiving anything new, really. So now I have a 1 at the very end. So it's 1, 0, 1, 0, 1, which is what I put in. Let's do a 0 here, and we'll shift that, and then the far output light box should come on as well. See, there we go. And if I shift it again, it'll turn it back off. It'll just follow that order of the lights that are on the top there, because that's what's been loaded into this register. So this is a 5-state or 5-bit shift register, and it essentially acted like a 5-cycle delay. Acted as a delay, right? It's a delay of 5 clock cycles because it took me 5 cycles to get my first 1 loaded from the left and output all the way to the right. That's not the most impressive way to use a shift register. It's not the most complicated way, but it is one of the ways that they are used in very simple computing, and it's sort of a basic building block. So let's look a little bit closer at these enable gates. So I'm gonna go start with a 0 right here. So first thing I want to notice is the top. So the top, this 0 is open, so this is in a state of 0. Now if I wanted to pass a 1 here, if I wanted to make this stage 1, let's see what we need to do. So first, we need this gate to open, and this gate needs to close. So we need to switch both of those. Then we need, then I need to open this enable here. So that's 3 things. So whenever a previous stage back here is a 1 and it's passed here, it needs to do all 3 of those things. It needs to switch those top 2 gates, and it needs to enable this one here. So notice this actuator, when this red wheel is hit, this actuator will hit this this up arrow, which is what goes and presses these buttons here. So these all a little bit complicated, but maybe more buttons than I needed. I'm not sure, but they need to hit both of them at the same time. So it needs to switch both of these. That's why they all point to each other. Same with it works the same way with the 0. This actuator here will also hit this up one. That's why there's so many buttons on the top, because they both hit each other. The other thing, this forward arrow is what controls not only that one state, but it also hits that light box, or that string of light boxes, which is nice. It's an easy way to pass sort of that one value out of the register. And let's see, what else? All right, oh yeah, so let's look at the clock. Now the clock. So this right here is where it clocks in, but when it comes out, it's going to hit this blue one, and this blue one heads back to this main fan out. This is my main clock control. So these 6 arrow buttons fan out to all the other clocks on this whole machine. So let's follow this one, and goes left, goes here. So each of these fan out, so it controls all of the clocks at the same time, and those blue square actuators, they all feed it back to close the clock. That's how it closes these at the end of the cycle, so it only runs one time, which is what we want. You don't just want them repeatedly pressing buttons. That's weird in this game, and it doesn't. It's not controlled. So as long as when I press the clock cycle, and one of these wheels actuates, then it'll close all of the rest of the gates. So it doesn't need all of them to run to do it. So this is why these are all chained together this way. So now let's go back to our 0 bit right here. When the clock's activated, that previous stage, so this stage, will start sending whatever bit that it has. In this case, it's a 1. We see the 1 is enabled there, and it's in a state of 1. So it's going to send a 1 forward to this stage. But if you notice, this one is also going to turn, and it's enabled as 0. So it's going to pass the 0 forward through these buttons. So these are all identical, if you notice. So the outside actuator will go forward to hit that next enable. That's what controls that enable. And it's going to pass this 0 forward at the same time as it's being turned to a 1. I hope that makes sense. I think that makes sense. So because that timing of the wheels is all the same, it can do both of these during that time. If it were offset or staggered in some way, then this wouldn't work. But because they're on the same clock, this one will turn and send a 1 forward, just as this one sends it 0 forward. So you don't lose any of those bits. So now we got to look at the little bit more complex case, and where this game has its limitations. Besides the speed of the clock, which is very slow, it's actually about 13 seconds on this one, if you noticed, because the wheel turn is 10 seconds, and then when the clock hits again, these buttons stay actuated for another 3 seconds. So it's actually a 13-second clock, which is slow. Anyway, okay, so let's look. Right now, the load is in a 1. So I've got a state of 1, and this first bit's a 1. So that's actually fine. That's what we're going to test. But if you notice right here, that 1 is not enabled. Why? Why is it not enabled? Because I've already sent a 1. Sorry about the camera movement. So I've already sent a 1 to this stage. This is already a 1. So if I were to put another 1 here, that would mean it's going to actuate here. It's going to just turn it off, and then it's not going to be a 1 anymore. It's going to flip. This is going to actuate up here. It's going to hit those again, and it's actually going to switch it to a 0. And we don't want that. That's not how this machine's supposed to work. So you can't actually push a 1 into a 1 actively. You just have to sort of work around that and tell the previous stage not to press the button again, which is how this one works. So when this load wheel passed a 1 to this stage, it also turned off its own 1 side enable, the red side. So now when I press the clock, this one's not gonna mess with this stage, but you'll see the rest of the register works right. So you'll still have a 1 there, and everything's gonna shift. So let's see that. So notice our 1 got shifted out on the very end. Now it's 0, 1, 0, and then 1, 1. Perfect, that's what we want. So notice here, the load is still in a 1. It's not enabled because, again, this is still in a 1 state. And look here, this already passed its state of 1 forward to this stage. And so this enable is now blocked off. So that's how we handle the multiple same inputs in a row. This is how this handles it, is by doing that. That makes it complicated to try to add parallel loading. I'm not going to get into how and why in this video, But these enables are important for making this work here. But it doesn't break the ability of this machine to handle 0 inputs later. So this is now ones. I can do as many ones in a row as I like. I'll do one more. And it'll just shift. So what's really happening, instead of it shifting each of those earlier ones that are on the left, it really just shifts the most forward bit. So it's slightly different from a true shift register, but it works effectively here. So the output is still the same. The result is sort of the same, at least in terms of how I've applied this. Notice those lights are what we expect them to be. And I'm going to load now 0, and we'll see it still will take the new 0. So now it's just sort of going to shift that 0 forward, just as that most forward, most 1 will keep shifting. And these ones sort of trapped in the middle don't really change. So now that first one, that's where I loaded the 0. This one didn't actually change at all. This one went to a disable because this is in the middle of the 3 ones. 1, 1, 1. Then we have our 0 and our 1 output. So it's shifting to the right, which is actually pretty cool. Alright, so this is ultimately why this register is really only an approximation. So you can't, as I sort of mentioned earlier, you can't truly load a new 1 or a new 0 into any stage that has a 1 or 0 already in it. You can only really switch it from one to the other, which is kind of the workaround for this game. This is a limitation of the buttons. This is why this is sort of just a model for electronic circuits. Real electronic circuits work differently, obviously. But the idea in the display is still there. The functionality is there, I think. I have ideas on how to make this work in more interesting ways for us. But anyway, it's a lot of fun. So I don't know if we need to test every type of input, because there's really any number of inputs we can do. It will work. I've tested this quite a bit. So now I've got 2 zeros there, and I've got my 3 ones. Multiple bits in a row does not break it. It just behaves a little bit differently. I'm going to load one more 1 just so we can go back and forth without problems. So loaded 1, I've got two zeros, 2 ones, and also the 1 at the output. And actually, this is one more thing I want to point out. This is kind of cool. So it's a 1 here, and you may have picked up on this, but notice that 1's disabled. That's what's keeping this from turning off. So it's still going through the clock cycle, and it keeps this light on. So the output, it does effectively work in the way that a true 1, 1, 1 would work in a clock cycle. If you had 3 ones in a row, it would keep the output as a 1. It's just that in this game everything switches on or off, which means you have to be really clever about how you apply these machines. So I just clocked that 3 times and this light box stayed on. It never went off. Now it will come off the next one, if you notice. But it works to delay that like that. But I'm also curious about how I might be able to apply some parallel outputs by using basically those actuators that I've got using those light boxes on the top. That's where I'm thinking for the next project. So I hope you all will check that out. This is, I think, everything I want to cover in this video. So like I said, I'm going to try to make this more functional in the future. I really would love to see how far I can go in making like the world's slowest microprocessor in this game. Share your own thoughts, creative ideas, especially if you can do any of this stuff better. I'd love to see other people trying to use these. Minecraft is much better redstone, but this is kind of fun to play with. So anyway, thanks a lot for watching.